Okay, so my project, my venture is called Eightsix Science. It's all about brain replacement and transplantation systems, because my end goal is really to cure death and make it really hard to die, so that dying itself is very not common anymore in the universe. The thing is really, I mean, we're all born at some point, we die at some point. That's as it always was in the history of life. And there are some approaches how we can, for example, extend life to its max, right? So we can delay death, but there's also some case where we can reverse aging. There's people working on that, like genetic engineering, for example. However, I want to pinpoint that like dying itself is still way too easy to happen. Even if you are Brian Johnson, super healthy, you can still get stabbed in the face and you're dying. Basically, it's super easy to die, and it's pretty absurd. And the reason to that, right, is your mind is where your body are, and the goal would be actually to separate your mind from your body. So if your body dies, your mind is still intact. So this is how it would look like, again, the same diagram. So your mind goes on into a new body, virtual robot, whatever. And this is not something new. People are working on this. I'm pretty sure at the conference there's some people working on like substrate independent minds. That the most prominent approach to that is mind uploading. It's really about scan the brain, store it on a computer, and simulate it, basically. And the whole idea is like, okay, if you're a brain that has like your mind, it's all inside your body, and you try to basically create a computerized brain and then try to upload or transfer your mind to that computer. So it would look something like this, right? So your biological body, your biological mind, and at some point you have your uploaded mind and your computerized brain. There's only a few problems with that. I'm quite outspoken about all of this. I will show you a link at the end of the talk. So it's really like so you die, the original you dies, and the copy might live on. But it's really the question, like, is it really you? Is the simulation sufficient? Can a computer program just be conscious? Is conscious just a computer program? There's so many unanswered questions to mind uploading, actually. So it's all these questions, nobody really has an answer. And I think even the people working with that, they don't really have an answer. They just base it mostly on beliefs. And I think it's really bad. So what I'm saying is that classical mind uploading won't work. Instead, I want to focus on something that we already know works, which is real biological brains. And this is really the focus of the talk, because I've developed an approach to a biological approach to mind uploading. And I think it's really the best shot we have at solving death and making it really hard to die. And the idea is basically brain in a vat scenario. I call it ectopic cognitive preservation. And it's using biohybrid brains, so mixed of tech and biology, that are optimized for long-term preservation and virtual reality integration. So it's like take your biological brain and turn it into this optimized biohybrid biology tech blend brain. And how does that work? That's really like the focus also of what I applied to for the Shift grant is step one, which is biohybrid progressive brain replacement. So we slowly take the brain, slowly kill small parts of the brain and add new cloned brain tissue that we engineer in the laboratory to it, and do that over and over again until at some point you have an entire young, healthy brain again that is still inside your skull. A big difference here is, I mean, there's also there's actually people working on this as well at ARPA-H, maybe some people know him. But the key difference here is that these grafts, like these small pieces of the brains that we insert into the existing brain, are actually mixed with small electronics and small particles. So what this enables us is basically you have a young, healthy brain again, but also a super high resolution brain-computer interface at the same time. So this means you can read and write from that new brain tissue. Because the second step is pretty straightforward: take the brain out, and as a third step, put it into a large-scale perfusion system and hook it up through that high resolution brain-computer interface to let the brain live in virtual reality. So it's really the Matrix scenario in a sense. And it's really funny. I always say like death is 3 engineering projects away from being solved. Like all of that stuff is being worked on. For example, the image on the right was a project I used to work on before I started this project. And that was really the key for the Shift grant application was, how do you create these small brains actually in the laboratory? And the process here is to print them with a bioprinter. And it's also about like creating a software that prints them first on the computer in silicon, so it's like virtual bioprinting, loops over it, iterates it, finds the best parameters, and then actually sends it to the real bioprinter, so that later these small brain pieces mixed with electronics can be inserted surgically into the human brain. And it's really the whole procedure looks something like that. You take a brain scan, you mix it with brain atlas data, you create a digital scaffold, you iterate over it, and then you send it to a bioprinter, which will enable the progressive brain replacement. So we I have like a bunch of people that also help me. We also have like some brain phantom, where we already are developing the surgical procedure of how this would work, how you cut out the piece, how you reduce the bleeding, how you like promote neurite outgrowth and all that stuff. So it's quite fancy. And just as a last thing, that's something I worked on in a previous company, which still exists. It's an amazing company. And I was the project leader, main developer and research, which is a brain in a vat. So a proof of concept of a butterfly living in virtual reality for several weeks, where users can actually interact with it over a simple website. And the brain organoid here on the right was like inside these perfusion systems, but for very small brains, obviously, and lived in VR, basically. So that was the proof concept. So it's really like it already works just for very small brains, and now we just need to make it work for really big brains like the human brain. And as a last thing, a small ad, I wrote the piece together with a Japanese professor on mind uploading, where we talk about all of that stuff in a lot of detail. So if somebody wants to read up on it, and also the approach I just talked about, and also some of the tissue engineering aspects, have a read. It's really it's a nice piece of essay. Yeah.